Hello, everyone. My name is Kerry O'Connor. I'm the Membership Development Manager with the RDS. RDS membership is delighted to have Professor Peter Mitchell speaking to us today about the Irish Radium Institute from 1914 to 1952. Peter was Professor of Physics at UCD. He's former head of UCD's School of Physics and a past secretary of the Royal Irish Academy. He is active in research and consultancy, specializing in radiation physics, radioecology, and radiological protection. He has published extensively in these fields, and he continues to serve on the editorial board of several international journals. He has made significant contributions to national and international institutions, including the European Commission. Peter, if you'd like to start your presentation now.
Thank you very much, Kerry. Ladies and gentlemen, good evening, and thank you all for logging into this short presentation arranged by the Royal Dublin Society, and particular thanks to your president, Professor Owen Lewis, who kindly invited me to give this short talk. At the outset, I must emphasize the difficulty of doing full justice to this splendid initiative by the RDS over a century ago, in a brief talk of a mere 30 minutes or so. For that reason, I would draw your attention to some excellent articles on the topic published by the RDS and others over the years, and cited on my final slide. My objectives are, I hope, straightforward. Firstly, to provide an overview of the history of the Irish Radium Institute, founded with great foresight in 1914 under the auspices of the RDS. To briefly outline the celebrated Dublin method of radium therapy developed at the Institute, and to recall the role of three exceptional individuals in the Institute's development, namely Professor John Joly of TCD and the RDS, Dr. Walter Stevenson, Dr. Stevens Hospital, and Mr. Richard Moss of the RDS as well. Perhaps some background would be helpful. In 1900, following the discoveries of X-rays by Wilhelm Röntgen in 1895, that of radioactivity by Henri Becquerel in 1896, and radium by Pierre and Marie Curie in 1898, John McClelland came to Dublin from the Cavendish Laboratory in Cambridge as Professor of Physics in University College, and in 1903, at his suggestion, the RDS purchased 60 milligrams of radium bromide to enable him to continue his researches on radium and its emanations. McClelland published widely, and through his researches, and those of a growing number of others abroad, science and medicine circles in Dublin became well informed on the properties of radium and its potential therapeutic use. Foremost in this regard was Professor John Joly of Trinity College, together with the Young Medical College, Dr. Walter Stevenson, supported by the RDS analyst, Mr. Richard Moss. John Joly was a Fellow of the Royal Society in London. He was also Professor of Geology at Trinity, and reputedly was possessed of an exceptionally wide range of interests. Inventions included the Joly calorimeter and a method of colored photography. He famously dated the age of the Earth. He didn't always get it absolutely right, but he was celebrated even for that. He served as Honorary Secretary of the Royal Dublin Society from 1897 to 1909, Vice President in 1912, and President for 3 years from 1929 to 1932, pardon me. Walter Stevenson was appointed in 1904 as Assistant Surgeon and so-called X-ray Officer to Dr. Stevens Hospital. Unlike most of the early workers in this field, he used X-rays for both diagnosis and therapy. He never relinquished his surgical practice, though his main contribution to the development of radiology in Ireland was in the field of radiotherapy. His collaboration with Joly began soon after his appointment to Dr. Stevens Hospital, and ultimately led to the foundation of the Irish Radium Institute in 1914, and as we've said, the celebrated Dublin method of radium treatment. Richard Moss was appointed in April 1875 as keeper of the minerals and analyst at the ODS in the room of Dr. J. Emerson Reynolds, elected professor of chemistry at TCD. In March 1878, he was promoted to be registrar of the ODS, but interestingly, continued as analyst and developed a highly efficient analytical laboratory, which dealt with a surprisingly wide range of products, later to include radium and its daughter product, radon. He was a skilled analyst and glassblower with experience of handling very small quantities of rare gases, both of which were to prove crucial to the developments being recalled here. It might be appropriate to say a few words about radiological safety. The field of radiological protection was in its infancy at the beginning of the 20th century. The risks associated with working with ionizing radiation, be it X-rays, or the radiations emitted by radium and its decay products, were only beginning to be appreciated. Sadly, Stevenson paid the penalty of repeatedly handling radioactive materials and lost the tips of some fingers due to radiation burns. Indeed, Joly considers his early death at 54 a calamity for the advancement of research into the medical uses of radioactivity. I might add here that Marie Curie herself died in 1934 from radiation sickness, apparently aplastic anemia. It's perhaps appropriate to say a few words also about the nature of the atomic nucleus. Forgive me if I'm insulting any in my audience. The nucleus, as you doubtless appreciate, is a tightly bound mass made up of positively charged protons and neutrons, which have no net charge. Because the mass of the proton, or neutron, is approximately 2,000 times larger than that of the electron, nearly all the mass of the atom is concentrated in the nucleus. The celebrated and famous chemist Dmitry Mendeleev, in 1869, was the first to formulate the periodic law and create a far-sighted version of the so-called periodic table. Indeed, he was given honorary membership of the ODS for his achievements. And if you cast an eye at that chart below right, you will see a couple of black arrows pointing to the position of radium 88 and radon 86. And of course, when we say radon 88, we are referring to the atomic number 88 of radium and the atomic number of radon 86. That table is structured where the ionization energy and the electron affinity of the various elements increases from left to right and from bottom to top, whereas the atomic radius increases from top right to bottom left. There are many different decay modes in which unstable atoms decay with the emission of ionizing radiation. The main types resulting from such decay are alpha radiation, beta minus radiation, beta plus radiation, gamma radiation, which is very penetrating, X-rays, also very penetrating, and of course, neutrons. This is a chart of the uranium decay series. And we're speaking here of uranium-235 and uranium-238. Were you to take a sample of soil from your back garden and analyze it for uranium, you'd find that most of the very tiny quantity of uranium in that soil sample would be uranium-238, about 99.3%. And 0.7% by weight would be uranium-235. If you look from the top right, looking down across to the bottom left, about halfway down, you will see the position of radium-226 and radon-222, the daughter following the decay of radium-226 in the middle of those decay series. It's perhaps easier to see what I'm talking about here. Radium is a descendant of uranium-238, and it undergoes decay in about 3.8 days, half-life, to radon-222. Radon, of course, is gaseous. The radon in turn decays to other radioactive daughters and granddaughters, all of which are either alpha emitters or beta emitters, and so on. And eventually the decay chain reaches lead-206, which is stable, insofar as we know anything is stable, against radioactive decay. Anyway, a little background on the Irish Radium Institute, and here I'm quoting from John Joly. Joly's interest in the therapeutic value of radioactive treatment of disease originated some years before the Institute was founded in 1914, somewhere around 1904. At that period, I was one of the governors of Dr. Stephen's Hospital. A case of facial rodent ulcer was brought to my notice by one of the junior surgeons, Dr. Walter Stevenson, as intractable to treatment. I had at that time in my possession 4 milligrams of radium bromide sealed in 2 glass tubes. As a result of exposure to the rays emitted by these tubes, from of course the radium bromide, the radon in fact, the rodent ulcer rapidly healed. So early in 1914, the Committee of Science of the ODS, upon Joly's suggestion, had under their consideration the desirability of approaching the Council of the Society with a view to the establishment of a Radium Institute in Ireland. The Science Committee agreed and passed the following resolution. The committee unanimously recommend the Council to vote the sum of £1,000 to purchase radium in addition to the Society's present stock. The committee further unanimously recommend the Council to take steps to found a Radium Institute and appoint the following committee to draw up a report formulating a scheme for a fete to be held in the year 1915. Professors Joly, McClelland, Purser, Dr. Adeny, Dr. McWeeny, Professor Dixon, Sir Howard Grubb, and the honorary officers of the Society. Radium was very expensive. Not alone was it expensive, but it proved difficult and laborious to separate from its mother material, pitchblende. In fact, you probably managed to extract about 1 milligram of radium from almost 10 metric tons of pitchblende. The demand internationally had, of course, become very great, so it became very expensive, particularly as time progressed in those early years. For example, in 1903, the ODS purchased 60 milligrams of radium bromide for less than £50, whereas by September 1914, 200 milligrams cost the Society £3,000. In today's terms, adjusted for inflation, this apparently is equivalent to almost £350,000. Bear in mind that at that time, 1914, the ODS was housed in Leinster House. This was the home to the Society since 1814. And it remained their home until 1923, when the move to Ballsbridge commenced, Ballsbridge opening in 1925. Anyway, the response of the Council to the recommendation of its Science Committee was as follows. On the 16th of February 1914, the response from Council was considered by the Radium Committee. 1, that the Radium Committee be asked to frame a scheme under which the radium it is now decided to purchase, together with that already in the Society's possession, shall be utilized. The scheme to be submitted at the next meeting of the Council. And 2, to arrange for the purchase of radium for which £1,000 has been voted. Only a week later, on the 26th of February, a minute of the Radium Committee submitting draft regulations under which the radium may be used and a draft circular letter asking for subscriptions towards the proposed Radium Institute were before the Council and were agreed to. And so the new Radium Institute commenced its activities under a committee nominated by the Science Committee and appointed by the Council to carry out the regulations. Subsequently, Joly, in writing the history of the Radium Institute, stressed the key practical role played by Mr. Richard Moss, highlighting, and quote, the delicate operations involved in bringing the priceless radium salts into solution, the development of methods for the separation and purification of the tiny emanations evolved, and its equal distribution into the finest of glass capillaries. All this in presence of the personal risks attending painful and dangerous sores arising from the penetrating rays passing through almost every obstacle. Specifically, Richard Moss's operation involved, firstly, getting the radium salt into solution, then developing a method for the separation and purification of the minute quantities of emanation involved. Following, the drawing off of the pure gas, radon, as I've said, into a long, fine glass capillary. And finally, subdividing this capillary into a number of emanation-filled glass tubes, each about 1.5 centimeters in length and small enough to fit inside thin-walled serum needles. A major difficulty in the purification process was the very low temperature required to freeze the emanation, minus 71 degrees Celsius. Now that's 71 degrees Celsius below the freezing point of water. But here the Society had a great stroke of luck in the form of a gift in 1906 from the brothers William and Samuel Geoghegan of a costly piece of apparatus for making liquid air. You can liquefy air at about minus 194 degrees Celsius. It's interesting to recall that when the therapeutic value of the radioactive treatment of disease began to be recognized worldwide, Joly and Stevenson actually visited hospitals in the London area and came to the conclusion that the practice of placing one or more strong radiants, as they called it, in the tumor was wasteful, injurious, and required heavy screening. To circumvent these issues, Joly, at a meeting of the ODS in March 1914, suggested the division of some radium or its emanation into a large number of comparatively small quantities for the convenience of inserting a number of foci of illumination so as to give a more uniform irradiation of a tumor. Quoting Joly again, we may omit wasteful screening. The illumination becomes more uniform. Cross-raying is favored. The distribution of illumination is under control. In short, the method possesses all the advantages which a small number of lights possess over one central lamp when a large space has to be illuminated. And thus was born the celebrated emanations of radium technique, or the so-called Dublin method. Accordingly, in place of a central tube containing, for the sake of argument, 200 millicuries of radioactivity, screened by 2 or 3 millimeters of lead filter folded around it, there might now be, in the new method, 20 needles, each of 10 millicuries. You can see some radium needles implanted to treat a case of breast cancer in the photograph on the right of your screen. Thus, Joly and Stevenson produced the forerunner of the radium needle. Because of the popularity, of course, and celebrated benefits of radium, there was quite a bit of radioactive quackery about at the time. People were marketing black boot polish with the name radium on top. There was no radium, of course, in the polish. They were similarly offering water as a cure for the living dead, as they called it. In 1932, one enthusiastic customer died actually of radium poisoning because there was some radium in these water samples. In addition to that, there was something called a radium doctrinator, dare I say, a radium sex aid. I don't think we need to go into that here, but you can see the sort of thing that went on in those days, just as it does, I guess, today. You even had radium prophylactics and so-called radium cigarettes. Now, there was no added radium in the cigarettes, other than any radium that might have occurred in very tiny quantities naturally. By the beginning of 1930, the demand for emanations of radium, as supplied to the physician, had so greatly increased that the Institute was no longer able to supply what was required. This despite a loan from the Medical Research Council in Britain in 1920 of 220 milligrams of radium element. So an appeal to the Society's members and to the general public became imperative. It is remarkable that in the course of a few months, a total of nearly 10,000 pounds was subscribed, about 600,000 in today's terms, which enabled the Institute to acquire an additional 496 milligrams by year's end. There were many, many distinguished personalities and others who contributed to this special appeal, to this special fund. And these included His Excellency the Governor General of the Irish Free State, the Right Honourable the Earl of Ivy, the Honourable A.E. Guinness, Lieutenant Colonel the Right Honourable Walter Guinness, the Royal Dublin Society itself, who contributed £1,000, the Irish Bank Standing Committee, Professor John Joly, who contributed 500 from his own resources, and indeed the famous singer and personality, Count John McCormack, who contributed £105. Sad to say, the Radium Institute closed in 1952. The radium on loan having been returned to the Medical Research Council in 1947, and the remaining 874 milligrams transferred to the newly established Cancer Association of Ireland, now known as St. Luke's Hospital. The novel method of radium therapy devised and implemented by Joly and Stevenson did not always receive due recognition abroad. However, many did indeed give credit to Dublin, and these are mentioned and referenced by David Murnaghan in an article in A Century of Medical Radiation in Ireland, published by Anniversary Press in 1995. In closing, it is salutary to reflect on the initiative and energy behind the establishment of the Irish Radium Institute. One can only but be impressed by the determination and dedication of all involved. True, our focus has been on three very exceptional personalities, but without the support of the Council and membership of the Royal Dublin Society, as well as numerous benefactors, and on the eve of the First World War, this most worthy of projects might well have stalled, to the detriment of the thousands of patients in Dublin hospitals who were subsequently treated with radium and its emanations over a period of 38 years. There's a short list here of further reading, which I should draw your attention to. I don't propose to read through it, but it is available. And you can see publications by Joly, by Dennis Crowley, the late Dennis Crowley, by David Murnaghan, and by Patrick Wise-Jackson. They're all there. In conclusion, can I thank you all for your participation and patience in these challenging days. Thank you very much.
Peter, thank you so much for a wonderful presentation. It was very, very interesting.
Well, I hope it's at least clear anyway, that yes, the sound is all right for you. You're very good. You're very good. But anyway, I hope it's all right.
Yes. We just, when you mentioned there on your finishing note about participation, we've had an email from a member, Adrian Summerfield, and Adrian refers, I believe, to his work experience in the early 1950s.
Yes.
Says that while I was working for my PhD in chemistry at the same laboratory in Trinity College as Peter Schwarz, who had been a refugee from Nazi Germany in 1938 and had come to school here. He had one of those jobs available to impecunious students, which involved cycling out to the RDS once a fortnight to pump off the radon gas, which had accumulated from the radium bromide in the laboratory there. And he had to collect it in thin capillaries, which were then used to treat cancers. Originally, I think, at Stephen's Hospital, but later at St. Luke's in Rathgar. So it's lovely to see that insight from a member.
I can't but endorse that. I'm delighted to hear that. It is just lovely that he has made contact and told us about his experience. And we should say thank you to him and all others who contributed.
And thanks again, Peter. Thank you very much.
Thank you.